everyone. I'm Robin, CTO here at Load Impact, and we'll be presenting and demoing for you today. And I'm going to talk about performance testing in a DevOps environment, give a brief overview, and then I'll do a quick intro to K6, our open source load testing tool, and that will include a short demo. And after that, I will spend the remainder of the webinar on the topic of how to integrate load testing into an automation pipeline, and specifically how to do so with K6, Load Impact 4.0, and GitLab. So roughly 2 years ago, we sat down and discussed the future direction here at Load Impact. And we felt that performance testing was changing. We were seeing more developers using our service, and we heard that many organizations were going through internal changes, adopting DevOps as a mindset to building, testing, and operating their systems. And as part of this transformation, performance testing responsibilities were being partially shifted from QA engineers to developers. And we decided that we needed to update our product to adapt to these changes. And K6 and Load Impact 4.0 is the result of those efforts. So if we look at the DevOps workflow from a high-level perspective, there's code and tests being written by developers and QA engineers at the entry point of this pipeline. And code is then pushed to a version control system, whether that's on-premise, GitHub, or GitLab, etc. And the code push to the version control system triggers CI jobs and CI pipelines to start. And the jobs and stages in these CI pipelines are run, and we get a pass or fail result for each step or job in the pipeline. And failures are then fixed by developers or QA engineers, and code is pushed to version control again, and the process starts over until we have all the QA gatekeepers in the pipeline showing a green light. And then the deploy flow, whether it's manual or automated, takes over to push our products to production. And K6 and Load Impact 4.0 are built to fit nicely into these types of automation pipelines, as I'll be demoing here in this webinar. So as we build up to the CI integration demo, let's first start by having a look at K6. So we built K6 because we didn't find any other open source load testing tool that we felt was a good fit for the modern developer and DevOps workflow that we just had a look at in the other slide here, where you have individual developers furthest to the left, and developers have their local environments, so meaning they have terminals, local editors, and a version control system, so they need capabilities to run tests locally. Further up, we have the centralized version control system where the entire team contributes with code, whether application code or testing code. So the testing code needs to be version control friendly, and that's why everything in a K6 test is code. And after version control comes the automation and CI tools. So the load testing tool, when automating, needs to be able to be dropped into a CI environment and automation pipeline and be able to act as the performance gatekeeper stage. So passing or failing the code moving through the pipeline based on performance before it gets promoted to production and reach end users. And we decided to write K6 in a language that has seen good traction in DevOps tooling in general, so Go, and we decided to use JavaScript as the scripting language that the end users use to write the load tests. And the reason for choosing JavaScript is simply because it has such a huge mind share amongst developers and QA engineers. And we decided very early on that we needed to build K6 as an open source project, as we believe that it's essential for developer tooling to be open source. And we wanted to support also use cases that span from being able to run tests locally, so behind the firewall or on a local developer laptop, to running larger and geographically distributed tests on cloud infrastructure managed by us, Load Impact, as a cloud service. And we wanted tests to be movable. So we wanted tests to be able to move between local execution and cloud execution without being modified. And that's what we've enabled now with Load Impact 4.0. So in K6, in a K6 test, everything is code. So both the scripting logic, so the user scenario, as well as the test configuration is code. And the reason for this is that that's what developers expect from a modern load testing tool, and it's version control friendly, as we discussed just a minute ago, making test changes trackable like all other code changes. And given that also K6 scripting is done in ES6 JavaScript, we get support for modules, and thus the possibility to reuse code and script logic across tests, but as well as team members if you have a larger team participating in load testing. So this means, for example, if you're testing perhaps a website, you could divide the script logic and have a module, for example, per page. Or if you're testing an API, you could have one API endpoint per module, and then you can take these individual modules and combine them into more complex scenarios. So let's switch to my editor here, and we'll have a look at a quite simple K6 test that we'll be using throughout the demo here today. So this is what a K6 test looks like. At the top here, we have some import statements for importing functionality that we need in our test. The second part here is test configuration. So we have anything that pertains to the configuration of the test itself. So in this particular one, we have very few options. We have the first option here that specifies the traffic simulation. So we're going to run a test for a total duration of 15 seconds, and we have 3 different stages in the test. And the first stage ramps from 1 user to 25 users for 5 seconds. And then we stay flat at 25 users for 5 seconds, and then we ramp down to 0 users for another 5 seconds, so 15 seconds in total. And this second configuration option here is not going to be used initially. It's an extension used by the Load Impact Cloud service. So when we integrate this later with the Load Impact Cloud service, this name here is basically giving the test a name in the Load Impact Cloud UI. And down here we have the user scenario script logic. So this is a very, very simple test here. So we have use the group functionality in K6, which is a way to logically group code. So we use it here to represent a page, so the front page of this particular system that we're testing here. So we are making one request inside of this group. We're requesting the front page HTML of this testing system that we have. We get a response back, and we can use response here. For example, we check that the status code of the response is a 200 OK. So a check is like an assert in other types of testing frameworks, but there's a difference in that a check won't halt the execution. It will just record the Boolean result of the check so that we can do kind of statistics on it. And then in the end here, we have a sleep statement that basically says that we are simulating the user reading this page before moving on. All right. So the next step is to look at how we can run this test. So we're gonna switch to the command line now. So I have K6 installed already, so I have it readily accessible here. So we invoke K6 by typing K6. We're going to use the run command to run the test locally, so generate the traffic from my local machine here. So that's all we need to type, K6 run, and then the path to the test itself. So we get some output here saying the execution is local, the output is sent to my terminal. That's what the dash means. And then it's just the path to the test file here. Maximum 25 users, and its total duration is 15 seconds. We can see here we get some information regarding the group. So we have a front page group. Underneath the front page group, so slightly indented, is the status of the check I had. So here we have a green check mark saying the check's passed. And down here we have some metrics and the statistics for those metrics. So let's head back to the slides. So let's now have a look at the process that we need to go through at a high level to add this this load test to an automation pipeline. So we first need to create a test, so create our script. We then need to run some baseline tests, and I will go through each of these steps individually soon. The third step is to set up thresholds for pass-fail criteria. And the fourth step is setting up notifications. And then the last step is doing the actual integration with the CI tool to get the automated execution of the load tests. So we've already created the test configuration. So we're going to use this script that I just showed and had pre-prepared. So the next step is to run a baseline test. And a baseline test is a test you execute manually to find the base performance or normal performance levels of your system. So usually you run a test with a small amount of simulated users that you know your target system can handle just fine. So you know that the response times will be basically what the system is responding with by default. And we'll, for the purpose of this demonstration, we're going to consider the test run we just did as our baseline test. So we're going to have a look again at the command line to see the response times in this test, and we're going to use them as inputs to the next step, which is to set up our thresholds. And thresholds you want to set slightly above what you observe in your baseline test, as you want to fail the automation pipeline if you have a performance regression. So let's go have a look now in the terminal and see what we had as our response times here. So we'll be looking at this metric here, the HTTP request duration, which is the total duration of responses. And we're going to look at the 95th percentile as the statistic that we're going to set up a threshold for. So we see here that the baseline response time at the 95th percentile is 112 milliseconds. So we're going to go to our script now. So this is a configuration option. So now we're going to add a threshold here. And you can add as many thresholds as you want in a test. So let's see, HTTP rec duration. So you specify the name of the metric, and then you can provide one or more threshold expressions that you want to evaluate during the test. So we're going to say the 95th percentile, and we want the 95th percentile to stay below. So let's say we had the response time of 112. So we're going to put it at 200 milliseconds. We're going to save that. We're heading back to the terminal, and we're going to run this test again just to see what it looks like. So now we're executing, and K6 is evaluating our thresholds. It will evaluate the threshold throughout the test, but we're going to get the result at the end when it's evaluated across all the data points for this metric. So we can see again here that the 95th percentile response time is 112 milliseconds still. So we get this green check mark as that was below the 200 millisecond threshold that we just set. All right. So now that we have the threshold set up for our test, we need to decide how we want to be notified of test passes, but perhaps more importantly, the test failures. So if you already have something hooked up to your CI system or tool or service, you can probably skip this step. But if not, you can use Load Impact's integration with Slack, HipChat, or webhooks to send notifications. So let's have a quick look how that works. So we have, when you're inside of the app, you have in the left hand side menu here, you have an integrations tab. And here we have the integration options for being sent notifications from our system. So I've set up a notification or an integration with Slack. So I will be notified to a specific channel in a Slack organization when my tests pass or fail. And of course, for our cloud service to be able to send these notifications, it needs to know about the result of the test. So to go back to the terminal here, when I ran the test here locally, the cloud is completely unaware that I've run a test, and even less so the result of the test. So to actually have the cloud system be able to send a notification, we need to also send the results to the cloud. So to be able to do that, you can instruct K6 to stream the results to the cloud as it's running in real time. So even though the test traffic is being generated from my local machine here, the results will be streamed to the cloud service. So and be stored by insights, and it will be able to send these notifications. So to be able to make that work, you first need to sign in to your Load Impact account through K6, and you would do that by doing something like this, K6 login cloud, and then you provide your email address and your password. Now, I've already done this, so I'm already set up here. So I'll just go and type K6 run -o, so output to cloud, and then run my test like this again. So now we can see that the output changes slightly. It still says the execution is local, but now the output, instead of saying just dash, which means the terminal, it now says cloud, and we have this link here. So now the results are being sent to the cloud service, and we can go and have a look by copying this URL. And go have a look at the results here in Load Impact Insights. So this is what the results look like. We have overview here. We can see the thresholds pass, the checks pass, and there are no HTTP request response failures. And here we can see we have our threshold here. We can see our response time is below the red threshold level. We have our front page group here, and we can see the request and the response time for this request. We can see our check, and we can see the pass-fail nature of the check along the duration of the test. And if we go to my Slack here now, we can see that I've received two new notifications, one when the test was started and one when it was finished. And we can see that both are green, so the test went fine. It passed in this instance. All right, let's go back to the presentation. So now we have all the prerequisites completed to add our test to an automation pipeline. We have run K6, we have hooked it up to Load Impact Insights, so we get the results stored in the cloud, and we enabled integration with Slack to be notified of test pass and failures. So let's head into the demo now, the CI integration demo. And I'm going to use GitLab in this demonstration, both for version control and also for CI, so continuous integration. And I'm going to use two of the three major components that make up our new Load Impact 4.0 product. So let's start by first having a very quick high-level overview of Load Impact 4.0. So Load Impact 4.0 is made up of these three components. The first one being K6. So we've already had a look at K6. It's an open source load testing tool that you can use completely, locally on premise, and then you can connect it to the second component, Insights, And Load Impact Insights is the centerpiece of our cloud service, where you can store, analyze, trend, and share K6 test results. And it also integrates, as we saw, with Slack, HipChat, and webhooks for sending notifications when tests pass and fail. And the third component is Load Impact Cloud Execution. So cloud execution it's a very convenient extension of local execution. So when you need to run larger tests or geographically distributed tests without having to manage the infrastructure yourself. So you just change the command on the command line when you trigger a K6 test run, and instead of the test being run locally, generating traffic locally, we will package up the test, send it to the Load Impact Cloud, execute the cloud on our cloud infrastructure, and the results will be stored in Insights and available through the cloud service. And we'll specifically be using, in this demo, we'll be using K6 in a local execution mode, but instead of running from my machine, it's going to run from the GitLab CI system. And we're going to send the results to Insights, and then we have hooked up Slack. So we're using the integration with Slack to get notifications. All right, let's get into the demo. All right, so I've set up a repository here in GitLab. So I pre-prepared this. It's a very simple repository. There are two primary files that we'll look at. The first one is the configuration file that basically enables the CI/CD functionality in GitLab. And I should mention also, I'm using the hosted cloud version of GitLab. So this is not the locally hosted on-premise kind of hosting of GitLab, but they work exactly the same. So it's just because of the ease of use of getting started that I've used the hosted cloud service here. So if you add this .gitlab-ci.yml YAML file, you basically enable the CI/CD functionality for this particular repository or project, as they call it in GitLab. So it's quite a simple configuration. The first portion here, which is the most lines of code in this YAML file, is basically just for downloading the K6 binary, making sure it's available so we can actually trigger the load test itself. And then we have some caching here just to not have the binary download on every build. And the meat of this configuration is basically these three last lines here, which basically says we have a job in this particular CI pipeline called load test. And of course, in a real world scenario, you would have maybe like a unit test stage before this, something that sets up dependencies. And afterwards, this load test, you might have a deploy stage, et cetera, et cetera. But in this very contrived, simple scenario, we only have one job, which is running this load test. So we're going to use the downloaded, the script line here basically says we're going to use the downloaded K6 binary, trigger the run command, output the results to the cloud service, and then we point to the path of the script or the test script, which is also hosted in this repository. And it's the same script that I showed previously here locally on my computer. One thing to note here is that since we're sending the results to the cloud, we also need to configure K6 here in GitLab to be able to talk to the Load Impact Cloud Service API. So locally you can use the K6 login cloud command to log into your account, but there's another way to do it that I've used here in GitLab. Let's see, which is to set up an environment variable. So if we go to the settings page here for the CI/CD product in GitLab, they have this section here called variables. So here I've added an environment variable called K6_cloud_token, and then I've specified my API key here, which enables, so K6 will be able to read this environment variable when running the CI pipeline, which enables K6 to basically stream the results to Load Impact Insights. All right, let's go and make a change locally on my computer. So let's change this to lower threshold. Look in the change. We add a change here, so using some git commands. So now I'm acting as the local developer here, doing some changes to the code base. This instance, the load test itself. I'm pushing it now to the central repository being GitLab. So we can go back to repository here. And we can see that I pushed something a few seconds ago, and we can now go to the pipelines view here. And we can see that we have a pipeline triggered because of the code push. So we have this job here that we had defined in the configuration file called load test. Let's go have a look at it. So we're going to get some output from this execution of this job. And I didn't mention this in the beginning, but so the CI/CD product here in GitLab works the same way as many other CI and CD tools. So we did a webinar 6 months ago on Jenkins using a Jenkins file, and it's the same process. You basically define your CI automation pipeline in some configuration markup, and then you store it in your repository, and it gets picked up by the CI tool. And it triggers these jobs, and you just in the case here where we want to add a load test, you add a load test job basically to the pipeline that triggers a K6 test. So here we can see the output here from K6. So it's running. It's going to run for 15 seconds as we defined it. We get the outputs here. We can see, even though it's not colored, but we can see that the checks passed. We can see that the threshold passed, which means from K6 perspective, since the thresholds passed, the K6 application will return a 0 exit code to GitLab CI, which indicates that it was a successful execution, meaning that GitLab CI will pass this performance testing QA stage that we set up in our pipeline. And we can also see, we can copy the URL here, so we can go have a look at the results. So every test run that would be triggered in this CI flow in GitLab now would send the results to Load Impact Insights. You have all the results available here. You can go back and have a look at them. If you have run several, so as this pipeline keeps on running as developers are pushing code, you will get this overview of the trend of your tests, so how the performance of this particular system that you're testing, how it's trending over time. And we also, since we hooked this up to Slack, we also see that we got notifications again here, one when the test was started and one when it was finished. All right, so that concludes the GitLab CI integration demo. So a quick recap of K6 and Load Impact 4.0. So with K6, you write test cases in JavaScript and the EC6 flavor of JavaScript, to be precise, where you have module support. You store your test cases locally or in version control, so GitHub or GitLab that we just looked at. You can debug your test cases locally. You can run tests locally using K6. And you can also opt to stream the results to the cloud. So you store the results and get the benefits of trending and being able to hook up with the different chat tool integrations. And you can also run tests completely in the cloud by changing the command line if you would like to have those benefits of distributing the load test across different geographic regions, for example. And you can easily integrate K6 into CI tools like GitLab, Jenkins, Circle CI, and the process, as I mentioned, is very similar to all of these different tools. They work more or less the same way with the configuration file that gets picked up by the tool itself. And the results of the load test, you can choose to either store locally in some sort of artifact store, or you can push them to or stream them to Load Impact Insights for storage in the cloud. Here are some links to learn more. So If you're interested in giving K6 a try, I would recommend that you join the Slack team, where we have quite an active community of people asking questions and helping each other. And you also have the Low Impact K6 engineering team in there that answers questions regarding K6. We have more information on insights on the marketing site. We have a new documentation site regarding Load Impact 4.0, which you can check out if you're interested in that. And this example project that I demoed here is available on GitLab, so you can go look at that example if you want to try this out yourself. And as a final note, I would like to mention that Load Impact 4.0 is available as a free 30-day trial at loadimpact.com.